This video is about Chapter 6, Problem 57. The problem asks, how long does it take a motor to lift the piano 16 meters? So we already wrote down the things we know, and that is the power with the 2,750 watts, the mass of the piano at 385 kilograms, the distance the piano travels, or the height, at 16 meters, and we know that we need time. So the next thing we can do is draw a free body diagram. We have our piano, and we know since it's moving upwards that it has to have some sort of force pointing in the upwards direction. And you can name this whatever you want, but I'm just going to leave it here as capital F. Since we are on a planet, presumably Earth, there is also some kind of gravity acting on it. So you can call that force of weight, force of gravity, however you like. We don't know anything about what forces are pointing in the left or right direction, but based on the context of the problem, we can assume we don't have to worry about it. So looking at the things we know and the things we need, we can determine that the most likely equation we're going to need is power is equal to work divided by time. And as a reminder, since power and time are both scalars, it's not incredibly important to focus on making sure our work has the correct sign, because we're just going to ignore it for this particular problem. All right, so we are solving for time, so let's go ahead and rearrange that really quickly, just so we have everything in the correct position, and we end up instead with time is equal to work divided by power. Well, we already have power, so we need to calculate work. Work is stated as the force on an object times the distance the object moves. So how much work is done by this force on the object over the given distance. And here we know that at the very least this force F has to be equal to the force of weight. So we can say that our work force here is going to be mg times d. And that's just replacing this force with the weight force and delta d with d, because this d value is 16 meters from the ground. So delta d is 16 minus 0, or just 16. So now that we have our equation just in terms of things we know, we can rewrite it again. So our time is mgd divided by p. And notice we know all these things, so we can plug them in, no issue. Now we also lucked out because in this problem, everything is in its base unit. We don't have to do any conversions. So all we have to do is make sure to plug everything into our calculator correctly. Now for some of you, you are required to use only the basic calculators in your class, and that's okay. Just one thing I found to make it easier is to only to only calculate one thing at a time so that you don't lose any numbers in the middle. And then I also know that some of those online problem sets, which my school uses Lon Kappa, they're very particular about sig figs. So we're going to keep an eye on our sig figs as well as we calculate. Okay, so we have 3 number values on the top, 1 on the bottom. The lowest number of sig figs is going to be 3, so our answer is going to have 3 sig figs. And what we end up with, which I'll give you a second to calculate it before I write my answer, is going to be 21.97 seconds, or as I said with the correct number of sig figs, 22.0. And as always, we box our answer to the question so that everybody can be sure this is what our final result is.